Law of conservation of angular momentum. In the absence of an external torque, total angular momentum of the system will remain constant. L1 is equal to I L2. In the absence of an external torque, total angular momentum of the system will remain constant. जब किसी बॉडी पर एक्सटर्नल टॉर्क ना लगे और वो बॉडी रोटेट कर रही हो तो उसका एक्सटर्नल टॉर्क क्या होता है, उसका एंगुलर मोमेंटम क्या होता है, वो कांस्टेंट होता है, चेंज नहीं होता, कांस्टेंट होता है. It means that moment of inertia is inversely proportional to the angular velocity of the body, or omega is angular velocity बढ़ेगी, moment of inertia कम हो जाएगा. If a body rotates about its internal axis of rotation and no external torque acting uh, is acting along its angular is acting and its angular momentum will remains constant. If a body rotates about its internal axis of rotation and no external torque is acting, then its angular momentum will remain constant, and its moment of inertia, if its moment of inertia and angular velocity changes, if its moment of inertia and angular velocity changes. beaker beaker spinning on a table, beaker spinning on a table, where is the mass of the liquid and is w is the angular velocity. Initially I1 is equal to m1 r square, यानी moment of inertia is equal I1 is equal to m1 r square. Omega 1 is equal omega 1. L1 is equal to m1 r square omega 1. m1 m1 omega 1, m1 omega 1, there is m1 omega 1. Moment of inertia y omega 1 I1 L1 is equal to I1 omega. If adding water into beaker, its mass increases, and as we know that I is directly proportional to mass, so its moment of inertia will increases to I2, and its angular velocity will decrease to omega 2. Then L2 is equal to I2 omega 2 L1 is no external torque.